Welcome back, Physics 30. This video involves Unit 1B, Part 4 for vector and scalar quantities. It pertains to 21 to 31 of the duotang, and we'll be looking at determining the magnitude and direction of a resultant vector mathematically, given two or more vectors acting in two dimensions. So up until now we've been drawing scale diagrams, and you can see it's somewhat monotonous, and you may get a slightly different answer than your buddy, because a lot of human error comes into play there. So here we can find a mathematical method to use, and then add two or more non-collinear vectors mathematically to determine the resultant vector, then apply mathematical concepts such as the Pythagorean theorem and trig relationships in solving vector problems. Okay, so number one, what is the first thing you should do when you mathematically try to solve a vector addition problem? So even though we're not measuring things, making a scale diagram, you should make a quick sketch to visualize what the vector question is asking you. It's a good thing to have a visual there, and then you can apply the mathematical relationships. Okay, and looking back to earlier math classes, Pythagorean theorem, of course, a squared plus b squared equals c squared when you have a right triangle. So we'll look at vectors in which they do form a right triangle, so you can use this mathematical relationship. And of course, SOHCAHTOA, if you're familiar with that, that helps to give you a way of looking at the different ratios for a given angle. So sine of theta, opposite over hypotenuse. Cos, adjacent over hypotenuse. Tan, opposite over adjacent. And we'll be using those, and they'll be very handy in solving these questions. Okay, so here, read over there are sample problems in the duotang, so if you find that you're struggling with this, go back, read those. Complete the following when you have finished reading the problems. Mathematically add the following vectors to determine the resultant, and use the a squared plus b squared equals c squared relationship, and also you'll see that the tan ratio is the one that we'll be using here the most. So, if the first question here, if we want to find out what happens when we take a 35 centimeter north vector and combine it with a 42 centimeter west vector, so the first thing you should do is just simply sketch that to see what it looks like. So over here on the left hand side I did that. 35 north, 42 south. So a north and that's west. A north and a west vector make a right angle, so we can use a squared plus b squared equals c squared to figure out what the resultant. So again, the resultant goes from the starting point to the finish point. So a squared plus b squared equals c squared, and so 35 squared plus 42 squared equals c squared, and then we do that. Take the square root of each side, and we get 54.6717. And if we look at sig figs here, two sig figs here with the number 35, two sigs here with the number 42. So the 5 and the 4 I keep. The next digit's a 6, so the 4 gets bumped up to 5. Okay. Now, since the resultant is a vector, it needs a magnitude and direction. So you can see over here, using the given information. So try not to use your calculated answer here, because if you got a mistake here, that mistake will carry on to your answer. So if we take a look, we have the angle here. 42 represents the opposite side, 35 is the adjacent side, and the resultant is the hypotenuse. So we know the opposite and we know adjacent. If we use tangent, we'll be able to figure out what the angle is. So tan of theta equals 42 over 35. So theta is equal to the inverse tan of 42 divided by 35, and if you typed in your calculator, you get 50. Now in terms of the direction there, this resultant vector is north 50 degrees tilted in the west direction. So these kind of give you a hint as to what you use with that 50 degrees. North, 55 degrees, west. As you can see there, that's what I have as an answer. Okay, you try this next one. So if you like, pause the video at this point, sketch this out, figure out the magnitude, figure out the direction, and then state the final answer. Okay, if you did that question, you should get 25 kilometers west 56 degrees south. Or if you started south and went west, you would have got 34 south, 34 degrees west. So just to run down here as to how I got that, if you take a look here at what I have. So here's a sketch: 14 west, 21 south. A 14 squared plus 21 squared equals c squared. Solve for c, you get 25. And then opposite side, 21, over adjacent side, 14. Take the inverse 10, and we get 56. So west, 56 south. Okay. And I have one more here for you to do. I started it for you. 158 centimeters east and 185, I forgot to write the centimeters in there, so just slide that in there, centimeters south. So you can pause the video right now and see if you can figure that out. Okay, so if you had a chance to do that, you should get a resultant value of 243 centimeters east, 50 degrees south. Okay, so if you didn't get that, run through it again or ask me next time I'm around, and I can give you a hand with that. Okay, so I think I'll stop there. I'll make a part 2 to this video, and we'll look at adding two vectors that do not form a right triangle. That's going to involve the law of sines and cosines, so we'll see you shortly.